In this video, we're going to learn about two of the exponent rules, the product rule and power of products. Learning the exponent rules is important because they provide shortcuts for simplifying and manipulating expressions with exponents. These rules, they help streamline complex calculations and make solving equations more efficient. So let's take a look. Let's get started by multiplying 7 to the third power times 7 to the fifth power. And we're going to write it out the long way and look for a pattern. So 7 to the third power times 7 to the fifth power Now we can rewrite all these 7's as 7 to the eighth power. So notice that the base stayed the same. The base stayed as 7. And then also notice that 3 plus 5 is 8. We just added the exponents. So when we are multiplying two exponential numbers with the same base, we can just add the exponents. So this is known as the product of powers rule. And in general, it just says that x to the m power times x to the n power would equal x to the m plus n power. We add the exponents. So let's give that a try. So here we're simplifying x to the seventh power times x to the fifth power, same base. So we just add the exponents. Now here it's a little more complicated. We have a coefficient out in front, that 14. And that 5, the exponent, has nothing to do with the 14. In fact, this just means 14 times n to the fifth power times n to the 10th power. So we're going to multiply n to the fifth power times n to the 10th power by adding those exponents. And the 14 just tags along. So here we have 2x to the fourth power times 3x to the fifth power. Now 2x to the fourth power really means 2 times x to the fourth power. This is really 3 times x to the fifth power. Now when it's all multiplication, like this expression is, we can do the multiplication in any order we want. So we're going to multiply the regular numbers. 2 times 3 is 6. And then x to the fourth times x to the fifth, we use the product of powers rule. And we add the exponents. So we multiplied 2 times 3 and then use the exponent rule. So here we have different base letters. We have y's and z's. So we could rewrite this with the y's together and the z's together. Normally you would skip this step, but just to make it clear what's going on here. And now we see that we can add the exponents with the y's and add the exponents with the z's. So we get y to the ninth power times z to the 11th power. All right, it works with negative exponents as well. So here we're multiplying two exponential expressions with the same base. So we're just going to add the exponents. Well, 6 plus negative 4 is 2. So n to the sixth power times n to the negative fourth power equals n to the second power. Now this one's a little more complicated. Now the 3, you remember, has nothing to do with the exponents. It's just a coefficient out in front. So we'll use the exponent rule on these n's. So 2 plus negative 6 is negative 4. So this would be 3 times n to the negative fourth power. But let's rewrite this without negative exponents, which means that we're going to need to move these n's into the denominator. A negative exponent has nothing to do with negative numbers. It just has to do with fractions and things being in the wrong place. So I'm going to go ahead and set up a fraction here. Now remember, this is 3 times n to the negative fourth power, so that exponent has nothing to do with the 3. So the 3 is going to stay where it is up here in the numerator, but these n's are going to move down to the denominator, and when I do that, I get rid of the negative sign. So we get 3 over n to the fourth power. Let's investigate a little bit more. Now here we have a different situation. We have an exponential number raised to another exponent. So we have 8 squared, which is 8 times 8, raised to the 4th power, which would be 8 times 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 8. Well, if we count up all those 8s, we notice that there's 8 of them. So this would be 8 to the 8th power. So notice the base stayed the same, but this time with the exponents, when we are raising an exponent to an exponent, or a power to a power, we multiply. So when you're raising an exponential number or expression to a power, we multiply the exponents. Very closely related situation here. We do have a power to a power, but we have this 5, this coefficient, inside the parentheses. So let's go ahead and expand this out. So 5x to the 4th power, I'm going to write that out the long way. And then we're squaring it, so we're going to multiply that by itself. All right, so I'm going to write, so this would be 5 times 5, but I'm going to write that with exponents just so we can see what's going on a little more clearly. And then we count up all these x's, and there's 8 of them again. So looking back at the original question, notice that we treated this 5 like a regular number. It's just 5 to the 2nd power. So that exponent does work on that 5, but we're not using any special rule or anything like that. So we're not multiplying 5 times 2. It's 5 to the 2nd power, which will be 25. But then we use the power to a power rule to get x to the 8th power when we multiplied those exponents. So the main thing I'd like you to notice here in a situation like this is to treat regular numbers like regular numbers. That's just 5 squared, which is 25. Then we use the exponent rules for the x to the 4th raised to the 2nd power. Okay, let's summarize what we just investigated there. So x to the m power raised to the nth power would be x to the m times n power. Now here this k would be like a coefficient or a constant out in front. So this would be k to the n power times x to the m times n power. So we use the exponent rules on this exponent here, but we just treat the k, if it's a regular number, we treat it like a regular number. All right, so here we have an exponential expression raised to a power, so this is where we multiply. So this would be a to the 45th power. Good thing we didn't have to write that out the long way. Here we multiply again. We have an exponential number or expression raised to another power. So it'd be n to the negative 48th power. And let's rewrite that without a negative exponent. So the negative exponent just means move it to the denominator. So we had to make a fraction. And when we move these n's to the denominator, it gets rid of that negative sign. Now, since there's nothing left in the numerator, we fill in with a 1 because we don't want an empty numerator. All right, here we have a 7. It's not an exponent, so we're not going to use the exponent rules. But that 2 will still affect that 7. So we have 7 squared times x squared times z squared. Let's go ahead and simplify that by changing a 7 squared into a 49. Here we have an expression raised to the 5th power. Everything inside the parentheses is being multiplied, so we have 2 times x to the 9th power times b to the 5th power. So this 2 is a regular 2, so that'll be 2 to the 5th power. And then x to the 9th power raised to the 5th power, well, that's where we multiply, because we have a power to a power. So that'd be x to the 45th power. Then b to the 5th power raised to the 5th power. That's where we multiply, so that'd be b to the 25th power. So let's go ahead and simplify this. 2 to the 5th power, that's 32. So we have 32, x to the 45th power, b to the 25th power. And here we have a negative exponent. I think the easiest approach here, not the only approach, would be to get rid of that negative exponent first. So we're going to move this whole expression down to the denominator. So I make a fraction, and I move that 7c times c times n down to the denominator. I raise that to the 3rd power. When I moved it to the denominator, it got rid of that negative sign. Now our numerator is empty, so I'm going to fill in with a 1. Now let's go ahead and simplify the denominator. All right, 7 is a regular 7. Now 7 to the 3rd power, that's 343. Then I have c to the 3rd power and n to the 3rd power. Okay, on this one, I think before we start moving things around and moving things to the denominator, let's go ahead and use our power to a power rule. So a to the negative 3rd power raised to the 6th power, that's where we multiply. So it's going to be a to the negative 18th power. Then n to the negative 8th power raised to the 6th power. That'll be n to the negative 48th power. And k squared raised to the 6th power. That'll be k to the 12th power. So we're multiplying the exponents there. Now let's get rid of these negative signs by moving those particular pieces to the denominator. So we're going to move the a's to the denominator. When we do that, the negative sign goes away. We're going to move those n's to the denominator. But the k's do not have a negative exponent, so they're going to stay in the numerator. I hope these examples about the exponent rules, in particular the product rule and power of products, have been helpful. This is Mr. Ela, signing off.